There's a lot of chemistry that goes into making chocolate to ensure it's smooth and silky, breaks with a crisp snap and melts at the correct temperature. Chocolate's main ingredients are cocoa butter, cocoa solids, sugar, an emulsifier and flavourings. It's the cocoa butter, the fat obtained from cocoa beans, mainly consisting of oleic, palmitic and stearic fatty acids, which gives chocolate its physical structure. Cocoa butter is a polymorph. It can exist in more than one form. It actually exists in 6 different crystal structures, depending on temperature. Cocoa butter in crystal structure 5 gives a smooth chocolate bar. It's glossy, it has a superior mouthfeel, so chocolatiers aim for this. However, it's not as easy as you might imagine, and generating this crystal form doesn't happen by accident. The first step is to melt the chocolate to ensure there's no cocoa butter crystals at all. Then the temperature is dropped to just below where crystal structure 5 is made, which is usually just below 35 degrees Celsius. Hopefully this means that hardly any of the undesirable crystal structures are created. Form 6 crystals originate from Form 5, and you might have experienced this if you've rediscovered an old Easter egg in the back of a cupboard, tasted it and been disappointed at the flavour. These Form 6 crystals are caused by smaller crystals melting and coagulating. Larger crystals diffuse light, and this chocolate isn't glossy anymore, which is called Fatbloom. When the chocolate is at 35 degrees Celsius, some undesirable Form 4 crystals are generated. So you heat the mixture back up to just a little bit, so you should have only Form 5. And when you cool that down, the crystals will act like a template, manipulating the majority to take on that same shape. There are several tempering methods, but one which is still favoured is working with chocolate on a marble worktop. Here, once all the chocolate's melted, most of it is poured onto the cool surface, leaving a small amount warm in the bowl. It's then worked while it's cooled, pushing it backwards and forwards. Once it reaches a specific texture, it's poured back into the small portion of warm chocolate and beaten furiously. The easy way of tempering chocolate involves adding already tempered pieces to some melted chocolate, expecting the cocoa butter in the melted chocolate to follow the same structure as the perfectly tempered solid lumps. It's not just the shape of the crystals that's important. Size matters too. Smaller crystals ensure the chocolate has a high shine. They also taste better. You'll know how important tempering is if you've left chocolate somewhere warm by accident, like on a windowsill or in a hot car. You can really see the difference, and you can taste it too. Untempered chocolate is soft, containing a mix of crystal structures, some of which have already melted at room temperature. So the next time you eat a chocolate bar, remember to appreciate the micro-scale chemistry that goes into generating that melt-in-the-mouth chocolate. For more edible experiments and the chemistry behind certain foods, check out my other videos and demo sheets.